Hi. Um, this video is just intended to help you with this first weekly assignment and part one, deriving distance and midpoint formulas. So in this space on the assignment, I just want you to draw a Cartesian coordinate system, and let's emphasize the first quadrant. Y-axis, x-axis. Honestly, this analysis works in general in any quadrants, but it's maybe easiest if you're thinking in terms of positive coordinates. And then just locate a couple of points, not in specific locations, but just generically a pair of points. And let's call the first one x1 comma y1. And the second one, x2 comma y2. Don't let the subscripts bother you here. We just want to think of this as point number one and point number two. So the subscripts say this is x coordinate number one and x coordinate number two, to just distinguish between the two of them. We're interested in developing some kind of a formula that will work in general for finding the distance between 2 points. And we're talking about the straight line diagonal distance if we talk about how many units these are apart, even diagonally. And let's call the length of this line segment d for distance, for the distance between those 2 points. And just copy this down in this space, a figure like this. And then we want to come up with some kind of a formula that will always give us that length d. No matter where we put these points, we're going to be able to complete a right triangle where the distance that we're looking for is hypotenuse of the right triangle. So we're just completing dotting in the legs of this triangle. And then let's label this point the third vertex of the triangle. You'll notice that the first coordinate of this point, the x coordinate of this point, should be the same as the x coordinate for the point directly above it. So that would be x2, same location east and west as this point. And the height of the point down here, of this vertex, is actually the same as the height of our first point, right? So the y coordinate here is y1. Make sense? And then let's figure out, if we can, from these coordinates, what, say, the length of this leg of the triangle down here would be. This has an x-coordinate of x1, and this has an x-coordinate of x2. So on the x-axis, this would be x1, and this would be x2, right? I'll even label those x1 and x2. So the straight line distance between those, if you're thinking x2 is a larger number than x1, apparently here. If you do x2 minus x1, don't you get that length? So this is just the difference of the x-coordinates of these 2 points, x2 minus x1. And similarly, this leg of the triangle, this vertical leg of the triangle, is just the height of this point here minus the height of this point here. So it's y2 minus y1, just the difference in the y-coordinates of those 2 points. And this kind of gives us everything we need to develop a distance formula. Well, actually we need one more formula that you might remember about right triangles. We need the Pythagorean formula. And that's one that a lot of people remember really well. The Pythagorean theorem just says that the length of the hypotenuse squared is the sum of the squares of the lengths of the 2 legs. So that's usually written a squared plus b squared equals c squared. I'm going to write that Sorry about the banging of my little board in my office here. Let me write that in reverse order. C squared equals A squared plus B squared. And then let's fill in the parts of this formula, this Pythagorean theorem formula, from the right triangle that we've got in our figure. C squared is the square of what we're looking for, the square of the distance. A squared is the square of the length of one of these legs. So I'll copy down x2 minus x1, but square it, the squared length of this leg, and add to that b squared, the squared length of the vertical leg of the right triangle. So writing this out, d squared equals x squared minus, x1 minus x2 minus x1, difference in the x coordinates squared, plus y2 minus y1, difference in the y coordinates squared, is just filling in the Pythagorean theorem for this right triangle. And I'm almost all the way to a distance formula here. I just want to solve for d. I've got d squared here, so I'd like to take a square root of both sides. You might recall that in this kind of a equation in Math 95 or in another algebra class, when you take the square root of both sides, you want to be careful and say, if d squared is this stuff, then d is plus or minus one of the square roots of this other side. Although, in the situation we have here, we're going to be able to ignore that plus or minus sign. I hope you see why. D is a geometric length, right? This is going to be positive. I'm not going to have to worry about the negative square root. So, in general, this is always going to give you distance. If you have the coordinates of 2 points in the plane and you want to find the distance between them, it's going to be the square root of the squared difference between the x coordinates plus the squared difference between the y coordinates. In practice, you've got to take those differences and square them and add the sum first before you evaluate the square root. And then one other thing you can see in this figure, if you look carefully, is let me switch colors. Is you can use this same scheme to figure out a formula to locate the midpoint. Let me move my D over a little bit and just contemplate, what would I get if I tried to come up with a coordinates for the point that was halfway between x1, y1 and x2, y2 in the plane. And this is a little bit intuitive, but most people find it pretty clear when they consider the picture. Actually, the x-coordinate of the red point is just halfway between the x-coordinates of the two black points, or the two endpoints. Basically, the midpoint's going to be split the difference, halfway east and west, and it's also going to be halfway north and south. An easy way to capture that in a formula is to just say, take the coordinates of the original 2 points and average them. Add together and divide by 2. And same thing to come up with a second coordinate for the midpoint. Just add the y coordinates of the original points, y1 and y2, and divide by 2. Easy way to remember this formula, I think, rather than memorizing where all the subscripts go, is just to say average them. To find the midpoint, just average the coordinates, average the first coordinates, and average the second coordinates. And this red thing then is often called the midpoint formula. So when you're done with this part of the assignment, I want you to just reproduce this drawing and this algebra in the in this space in the written assignment. That's what I'll be looking for. And I'm hoping that that's an understandable way of seeing why the distance and midpoint formula works and maybe remembering them. And then in the box below, where you're supposed to fill in the, let me get my image out of here. You're supposed to fill in the distance and midpoint formula. It says given 2 points in the coordinate plane, x1, y1, and x2, y2, the distance between them and the midpoint of a line segment connecting them are, and here I'm dragging in another document, but basically just copy down these formulas which you'll use then in homework. Distance given here and midpoint given here. Okay, that's part 1. I'll see you in my next video.